Well, let's get caught up on the turntable project. This week I want to look at the wheels that go underneath the bridge. This has been, I think it's not an overstatement to say, a terrifying part of this project, because if at this point we will understand if the engineering works for this entire project or if it's just not going to work. And there's a lot of work that's gone into this project, and somehow this has simply got to be made to work. And I'm not 100% sure it's going to work. I'm not even 50% sure it's going to work. So there may be some trial and error in getting these wheels to work correctly. On a prototype bridge, the bridge is entirely supported on the ends by the wheels that ride on the ring rail. Let's take a look at the turntable at Golden, Colorado, and it's so well balanced you can see that they don't even have a motor driving it. They can just grab a hold of this heavy locomotive and rotate it around entirely by hand. Boy, I hope I don't have to do that with our turntable. If I can't get the motor to work, this is how ours is going to work too. Now, on the prototype at Durango, the ring rail really looks like it's a mess. The ties are all crooked and everything. But this ring rail has to be absolutely perfectly round and absolutely perfectly level. And so I've had to duplicate that on our turntable. And a lot of work has gone into making darn sure that this ring rail is perfectly round and as close to perfectly level as I can get it. It's off a little bit, but hopefully that won't be a problem. In order to make sure it's perfectly round, our friend Dwayne made us this template that locks in at the center so that as I'm spiking the rail in place, I can be 100% certain that it's absolutely round and absolutely centered on the center pivot in the middle of the turntable pit. And so with the ring rail completed, I can put the bridge in place and double check to make sure that the spacing between the bridge and the ring rail is as close to consistent as I can get it, because now I have to engineer where the wheels go underneath the bridge and ride on the ring rail. And I would like it if the wheels stay in contact with the ring rail. On our turntable, it's different than the prototype in that it is driven from the center. There's a motor in the center pivot, and that's what makes it go around. And the center pivot has been designed in such a way that it's going to carry most of the weight of the locomotive when it's on here. In fact, if the locomotive is perfectly centered on here, in theory, 100% of the weight will be riding on the bearing here in the center, and the ends will be touching the ring rail but not really supporting any weight. The wheels will only be carrying weight when the locomotive is pulling onto or off of the turntable, and the weight of the locomotive is directly above the ring rail. Jerry Day has some great photographs of how the mechanism works on the prototype at Durango. And it's a rather complicated piece of mechanism here that rides on top of the ring rail. There's a motor here that runs on compressed air. I assume that originally it ran on steam, but it seems now that it runs on compressed air. Anyway, the motor turns the wheels on the ring rail, rotating the turntable around the turntable pit. Just as with our model, in this case, as the locomotive is pulling on or off of the turntable, then all of the weight is transferred, in this case, to just one end of the turntable or the other. If the locomotive isn't perfectly centered on the bridge and they try to run the steam motor, typically the wheels will just slip if it's at the wrong end of the turntable because there's not enough weight on those wheels. Here we can see another photograph by Jerry Day showing the motor and the mechanism. It's geared down just as ours is, and you can see it's a pretty complicated mechanism, and I had no dreams about trying to recreate that on our turntable. That's why I've moved the motor to the center. And therefore, there will only be weight on our wheels when the locomotive is pulling on or off of the turntable. But if the ring rail isn't perfectly level, then it's going to ride up and create a friction, and well, it's going to be a problem. The other potential problem is a couple of our locomotives, especially the K36, are so large that they just barely fit on the turntable bridge. And if the weight isn't perfectly centered, then there's going to be binding at one end of the bridge or the other. Or I should say there'll be weight on the wheels at one end or the other, which could create binding. So that's another concern. Back when I was designing the turntable, I allowed this space right here for the wheels or supports or however that was going to work. I just at the time had no idea how I was going to go about that. And my assumption was once I get the bridge built and the ring rail in, then I'll be able to test a couple of ideas and see what works the best. In the planning phase, I had assumed that there was going to be a lot more space here than there actually was. By the time Steve built the wood bridge for us, and it's 1.5 inches thick, the spacing here is much closer than I thought it was going to be. And so I fabricated these little wood blocks to function as skids that would ride on top of the ring rail to check for alignment. And then I very carefully sanded those down on the belt sander until I got the spacing just exactly correct. Where there were high spots, and there were 2 of them, it really let me know. It sounded a little bit like a Nevada Northern diesel horn. The high spots shouldn't be much of a problem because they're actually only about 0.10 of an inch too high. And so I'm just going to kind of take those down with a Dremel sanding drum. Moreover, when the wheels are on here, it shouldn't matter that much if it rides up and down ever so slightly. But the most important feature here is that there has to be this exact spacing under the end of the bridge so that when a locomotive is pulling on here and the weight of the locomotive transfers onto the bridge, it doesn't deflect the bridge down and derail the train. It has to line up perfectly and be able to support that weight. And our heaviest locomotive weighs in at right around 50 pounds, and we have another one that weighs in at just over 30 pounds, possibly 35 pounds. So there's a lot of weight pressing down on the end of this bridge at times. And so my plan is to plane down these 2 high spots. They're not that high, as I say, and the reason is where the wheels will go over them without a problem. If the wheels can't carry this incredible weight, and they might not be able to, then I'm just going to leave these skids in place, because right now I can pull the locomotives on and off without a problem because the little wood skids can easily handle the weight. So in that case, the wheels would be more decorative. They won't be carrying the weight. In the meantime, I just want to make sure that I'm getting rid of these high spots. And they weren't that high, otherwise I wouldn't be dealing with them this way. But I just had to shave off maybe just a little bit more than 1/10,000th of an inch, so I wasn't planing it down by much. And so on to the construction of the actual wheels. Now, what I had envisioned to use as the wheel all along were these little ball bearings. They're not intended to be used this way. They're supposed to be pressed into some other mechanism, and this is just simply the bearing part. But looking at them, I thought, I can't see why the outside of that bearing can't actually just be the wheel that rides on the rail. And now that I could see the limited space that I have here between the bridge and the rail, I thought, just an angle bracket that holds this against the rail. and mounts directly to the side of the bridge. In what you're seeing here, I'm actually pressing it up against the plastic faceplate that goes over the bridge. I will cut that away so that these mount instead directly to the plywood bridge underneath. And so I cobbled together a quick prototype just as a proof of concept, something that I could tack in place with some double stick tape just to see what it looks like and how it functions, basically knowing that it couldn't carry any weight. It's just going to be held in place with double stick tape. But I think it looks just fine, and once it's mounted directly to the plywood with proper screws, it should carry a reasonable amount of weight. So 2 of these, 1 on each side, it may very well work out. In this case, I've removed the little wood skid, so the entire weight of the end of the bridge, just the end of the bridge, is resting on the one wheel. And it's operating quite smoothly. There's still a little hint of a high spot running through here, but because it's riding on the wheel instead of the skid, it doesn't bind up at all, and it seems like it's going to be just fine. And I think the alignment here at the end is just fine. So I think that's it. I think that I'll build 4 of those, and hopefully that will work out. I'm constructing them out of evergreen sheet styrene. I make a lot of stuff out of evergreen sheet styrene. That will make them strong, but not as strong as if I made them out of brass. But I'm planning to carry the bulk of the weight out in the middle, and so I don't think they need to be as strong as building them out of brass. Just a little tip here: when you're working with sheet styrene, it's better to take the back side of your blade and drag it backwards across the plastic, and then just score it and then snap it. I need 8 of the side pieces for the frames, so I've cut out 8 of these rectangles, trying to make them identical. And then I've added in the angle cut, again trying to match them all up so that they are identical. Then I took 1 of them and I marked out the position for the axle hole, and I went ahead and drilled that. And then I used that as a drilling guide to drill the other ones. Again, these need to be as close as possible to identical. The axles are constructed out of acrylic rod, clear acrylic rod as it happens, and those need to be turned down. They're a little too large, and they need to fit snugly inside the ball bearings that I'm using as wheels. And the only way I can make that work is to use an oversized rod and then turn it down slightly. I've got this goofy little, it's like a toy lathe. I bought it out of China. You see them all over eBay and stuff. They only cost a few dollars, and they're really just intended as a toy. But for turning down plastic like this, just free cutting it with a wood chisel, the thing works great. I have a Shoreline lathe, but I don't really know how to use it, and it's missing some parts. So anyway, I used this instead. It's a little bit tricky getting the exact diameter and keeping them absolutely straight, or as close to absolutely straight as I can, but it can be done. And then test fitting the ball bearing on here. Again, it has to fit really snugly on there because I don't want it spinning on the plastic. I want the ball bearing itself to spin. And then cutting them off with a saw, making sure that I'm getting them the proper length, of course. Again, this is all just being done by calculated eyeball because this is just a little toy lathe. And there they are. At least there's mostly 1 of them right there. 4 of these, exactly like this. And they spin quite easily. And again, they're not spinning on the plastic axle. It's the ball bearing itself that's turning. I'm not sure how much weight these can handle, and that's a concern because 2 of the locomotives are very heavy. But I don't think all of the weight's going to be riding on these wheels. It just depends on how I set up the bearing in the middle. On the prototype, 100% of the weight would be riding on these wheels, but my plan all along was to carry the bulk of the weight on the big center bearing. Anyway, we are ready for paint. I have masked off the wheel bearing area as best I can. I can touch up the paint on the plastic, but it would be very difficult to remove paint from the metal parts, so I'm trying to be very diligent about covering up the metal. Hopefully you've seen the show we did on the VMS primers and paint system. I'm going to be shooting these with VMS black primer and then just using that as the final color as well, adding weathering over the top of that. These are a water-based acrylic, so it's water cleanup, and with all paints, all primers especially, I work in very thin coats, many smaller, lighter coats. It works much better that way. So after about 5 of these thin coats, I think I've got everything well covered up, concentrating on getting down into the nooks and crannies. And then I came back with a lighter color and just kind of misted that over the top. This is the beginning of my weathering passes to make it look more like weathered metal down here. After stripping off the tape, I can see that there's a bunch of places where the tape blocked the paint from getting on the plastic, and I'm just going to touch that up with a brush and some regular craft acrylics. And then while everything's apart here is a good chance to start with a bit of dry brushing over the top of the whole thing, just to get some baseline weathering on here. Once everything's in place and working, I'm going to finish up with some oil streaks and that kind of thing. I had debated whether I wanted to mount these over the plastic sides or cut away the ends of the plastic slides so these mount directly to the plywood. But after a very small amount of consideration, I decided no, mounting them over the plastic this way would be a fool's errand. I'll cut that back and mount them directly to the plywood. The critical part of this alignment is that the wheels set the height of the rail where it matches up with the rails coming onto and off of the turntable. And I want to make sure this height is as close as I can possibly get it to the same on both sides. As the DCC controllers sit underneath this turntable, right now everything is torn apart and there's no power going to the track. But I did try just dragging the C19 here out onto the turntable to make sure that it transitions nicely onto and off of the turntable from both ends of the bridge. I found that there was one place where the wheels were losing contact with the rail, and that's because here at the rail joint had moved toward the outside, and so I tucked that up against the template and made sure it was properly spiked down so that the wheels stay in good contact with the rail all the way around. I've actually got the height adjustment in the center set right now so that 100% of the weight is riding on these wheels, and boy, I don't think they could handle the weight of a heavy locomotive on here, which is why I designed this initially to carry most of the weight here in the middle, and I've actually got a height adjustment here so I can now raise the bridge slightly so that most of the weight is riding here at the center, and there's really only weight on the wheels when a locomotive is pulling onto or off of the bridge. The only other time that there would be weight pressing down on these wheels is if the locomotive is not perfectly centered over the middle of the bridge, in which case it would tend to teeter-totter off to one side or the other, pressing down on the wheels. Hopefully this geometry is all going to work out okay. With no weight on the bridge, it's working great. It's being assisted by our good friend WD-40. I've spritzed a bit of that into the ball bearings at the ends, as well, of course, as the center bushing, to make sure that everything is totally free turning. And it goes around quite nicely and stays in alignment. And, well, without a locomotive on here, it's working just fine. And the ends of the bridge are matching up quite accurately with the approach rails. There are a couple of places where the bridge is, well, the weight is transferring more to the wheels at the outside edges and off of the center bushing, just slightly high areas on the outer ring rail. And so I'm just going to, once again, use the Dremel and lightly take the tops down by just a tiny, tiny fraction, less than the thickness of a piece of paper. And with a somewhat heavy locomotive on here, everything's still working. Of course, it's a bit stiffer, but it's still turning quite easily. So let's hook up the motor and see how that behaves. Boy, it was quite some time ago, several weeks ago, that we mounted the motor initially and put the belt on it and figured out how that was going to work. At that time, there was no ring rail or anything, and so now this is the first attempt at hooking the motor back up and seeing how it behaves running now from the electric motor instead of just spinning it around by hand. And boy, it's working great. Of course, it's working great with no locomotive on here. It remains to be seen what's going to happen when we roll some weight out here to see how the motor is going to behave when it's under a heavier load with a locomotive on here. Most of the locomotives have a similar weight here to the C19. I think the C19 is one of the heavier locomotives. Other than the two big brass locomotives, one weighs in at almost 40 pounds and the other one weighs in at something north of 50 pounds. So I'm going to risk my back and go ahead and lift the AccuCraft K27 up here, and sure enough, the motor's not at all happy about that. So I'm not sure what to think about this with the two big brass engines on here. I may try some adjustments. I can encourage it by hand, but boy, it'd be nice if it could turn these heavy locomotives too. And anyway, I am not too keen on the idea of reimagining all of the engineering on this for the heavier locomotives. So I'll just kind of mess around with that. In the meantime, it's working great for the other 30 locomotives, so I think I'm going to call this good enough, and if it won't turn the heavy locomotives without a little encouragement with putting a hand on there. After all, some of the turntables work entirely by hand, so I'll just pretend we're at Golden, Colorado and grab a hold of it and give it a manual shove. So I'm planning to just continue on now with the electronics, hook up the slip ring and the power reverser that goes to the bridge and the sound system. As you can hear, I've laid in a temporary version of the sound system here just to get a sense of that. Should be a lot of fun. Anyway, I hope you're going to want to follow along as we continue with the turntable project. We have a lot of other projects in the works. Karen's been doing some amazing stuff, and you're going to want to see that. And so if you're not a subscriber to the channel, please subscribe, and you can do that by clicking on the upcoming blue button. Zoink! Right there, the blue button. Well, we're not sure how you found this video on the internet. We hope you didn't find it boring, and we will see you here on Tuesday. See you then. Bye-bye.